Hello viewers, welcome to my channel. I'm Hasham Ali Khan. So in this video I'm going to explain you about the theory of measures of dispersion. In examination you may get a theory question also regarding dispersion. What are the different measures of dispersion? So without understanding the theoretical concept, if you go to the problems you will find it difficult. So before solving the problem you must have the ability to write the meaning of the different concepts. So in this video I'm going to explain you the dispersion, measures of dispersion. Dispersion is a statistical technique which is applied to find out how the individual values are deviating from the average value. The average is the measure of central tendency. Average is a single value representing a mass of data. So there are many advantages of calculating the average. We simply calculate one value out of the mass of data and we assume that this is a representative of the mass of data. But it is not without fail. It is not without limitation. So measure of central tendency, averages will have their own limitations. That is not the end of the statistical study. So after calculating the central tendency, we need to calculate the measure of dispersion. How the individual values are deviating from the average value. From the average value. If deviations are more, that means all the individual values are spreaded from the central value, are widely spread from the central value. That means the risk is more because individual values are spread away from the mean value. So mean value is not a representative of the individual values. Suppose if the values are all cluttered around the central value, then we can say that it is more reliable to depend on the average value because all other values are very near to the average value. So to study how the individual values are scattered around the mean, we apply the measure called measure of dispersion. In simple words, measure of dispersion is a statistical study which is concerned with finding out how the individual values are away from the middle value, from the average value. That is called dispersion. So meaning of dispersion completed. Now measures of dispersion. Broadly we divide the measures of dispersion into absolute measure and relative measure. In absolute measure, the dispersion will be calculated in terms of range, interquartile range or quartile deviation, mean deviation, standard deviation. These are the absolute measure of dispersion. Whereas relative measures of dispersion, when we are comparing two or more data, then we apply relative measure of dispersion. So relative measures of dispersion are coefficient of range, coefficient of quartile deviation, coefficient of mean deviation and coefficient of variation, CV. So these are the measures which are applied in order to study the dispersion of data from the average value. Now one by one we'll study range. The first easiest method of measuring the dispersion is range. Simply the range is the difference between the largest value and the smallest value. L stands for largest value, S stands for smallest value. So from the given data, we find out what is the highest value and what is the smallest value. The difference between highest and smallest value is the range, L minus S. The absolute measure of range is L minus S. Whereas relative measure of range is coefficient of range. That is L minus S divided by L plus S. So the easiest method of study of dispersion is by range. Next is quartile deviation. The quartile deviation. Quartile deviation will show the average deviation of quartiles from the median. Average deviations of the quartiles. Two quartiles are there, Q3 and Q1. Q3 is the upper quartile and Q1 is the lower quartile. So how the quartiles are deviated from the median value, that will be known by quartile deviation. The interquartile deviation is represented by Q3 minus Q1. Upper quartile minus lower quartile will give you interquartile deviation. Now semi-interquartile deviation or simply quartile deviation. The formula is Q3 minus Q1 divided by 2. This is the formula for quartile deviation. It is the absolute measure of dispersion. If you want the relative measure of dispersion, coefficient of quartile deviation, Q3 minus Q1 divided by Q3 plus Q1. The first method, range. Second method is quartile deviation. Third method is mean deviation. Mean deviation shows the average deviation of the values from the mean or median or mode, from the central value. The central value may be mean or median or mode. So we take the deviations. We take the individual values deviated from the middle value, from the mean value. Then we calculate the average. So average deviations of individual values from the respective average. The respective average may be mean or median or mode. The first thing, we calculate the mean. We calculate the deviations of individual values from mean and divided by 2. So we get the average. So the formula for mean deviation is equal to summation mod d. It is read as mod d. Read as mod d by n. And coefficient of mean deviation is equal to mean deviation divided by mean or median or mode. From whichever average you are taking the deviations, that average will take it in denominator. If deviations are taken from mean, denominator you will take mean. If deviations are taken from median, take the denominator as median or mode, like that. So mean deviation. The next measure of dispersion is standard deviation. The widely used measure of dispersion is standard deviation. So what is standard deviation? It's the square root of the arithmetic average. Square root of the arithmetic average of the square of deviations taken from the mean. Of the square of deviations taken from the mean. In simple words, it is a square root of the average of deviations, of square of deviations taken from the mean. So first of all, you calculate the mean. After calculating the mean, take the deviations. Then square the deviations. Square the deviations. Then calculate that squared deviation and put it under root. Calculate the squared deviation, average of squared deviation, and put it under root. You will get standard deviation. So how to calculate standard deviation? It depends on the nature of the series. Individual series or discrete series or continuous series. If it is individual series, standard deviation is equal to summation x square by n. Small x means deviations taken from actual mean. So if deviations are taken from actual mean, this is the formula. Sometimes deviations are taken from assumed mean. If the actual mean is in fraction, we take the deviations from assumed mean. In that case, the formula will be summation d square by n minus summation d wholes by n whole square under root. This formula will be applied when deviations are taken from assumed mean. When discrete series or continuous series, the formula will be standard deviation summation fx square by n under root. This formula will be applied when deviations are taken from actual mean. If deviations are taken from assumed mean, then standard deviation is equal to summation fd square by n minus summation fd by n whole square under root. So these are the formulas for calculating standard deviation. Next is variance. Variance means square of standard deviation. If you square the standard deviation, you will get variance, or standard deviation is equal to variance under root. If variance is given and you have to find out standard deviation, to put the variance under root, you will get standard deviation. If you are having standard deviation, you want the variance, to square the standard deviation, you will get variance. Then coefficient of variation. The coefficient of variation is a relative measure of dispersion, where we calculate the percentage of standard deviation over mean. Percentage of standard deviation over mean. So standard deviation by mean into 100, this will give you CV. If the CV is more, that means the deviation, the dispersion is more, variability is more. If the coefficient of variation CV is less, that means the deviations are less. That means all the values are very close to the average value. This is the conclusion regarding coefficient of variation. Now combine mean, combine standard deviation. To find out combined standard deviation, we need combined mean. Combined means mean the average, the mean of two groups. the mean of two groups is called combined mean. The formula for combined mean, x bar 1 2 is equal to n1 x bar 1 plus n2 x bar 2 divided by n1 plus n2. So if you have to find out combined standard deviation, then formula for combined standard deviation, sigma 1 2 is equal to n1 sigma 1 square plus n2 sigma 2 square plus n1 d1 square plus n2 d2 square divided by n1 plus n2 under root. Now here n1 matlab number of values in the first group, n2 number of values in the second group, sigma 1 square the standard deviation square of the first group, standard deviation square of the second group. Next, d1 square and d2 square. d1 square is equal to, d1 is equal to x bar 1 minus x bar 1 2 and d2 is equal to x bar 2 minus x bar 1 2. So this is the formula for calculating combined standard deviation. So in this video, only explanation I have given regarding what is the meaning of the term dispersion, what are the different formulas for calculating dispersion. So after listening this lecture, you can be able to write in examination if a theory question is asked regarding what is dispersion and what are the methods of calculating dispersion, or what is range, what is quartile deviation, what is mean deviation, what is standard deviation, what is coefficient of variation. This type of theory question will be asked in examination. So after watching this video, definitely you will be in a position to write about these concepts. But this is not the end of the matter. Apart from this, you go to the playlist of my channel, select the subject business statistics 1, select the topic measures of dispersion, select problems and do the problems on this range, quartile deviation, mean deviation. I have solved so many problems in the videos. Videos I have solved. So go to the playlist, select that part, watch the video, then you will get the complete command not only on theoretical concept but also on the problems. So this is the end of the discussion of measure of dispersion.